I am the Tofu Golem. Please enjoy the video.
You begin by confirming compatible driver, CUDA, and NSight versions. Mismatches break debugging. Once installed, set environment path and verify NVCC and NVIDIA NSight output so tools can find the GPU. Next, launch NSight and create or import your project. Choose the correct build configuration. Make sure to select local or remote target early because connection errors waste time. Finally, set build type to debug or rel with debinfo so symbols are available for step-through and kernel inspection. You now configure captures. Place breakpoints and timeline markers where performance or correctness concerns appear. Then choose capture tools, GPU trace for kernels, API trace for driver calls, memory view for allocations, and configure launch counters so you capture representative frames. Once done, run the application with a timed capture. Make sure capture depth and sampling reduce noise while preserving hotspots. If data is large, filter by PID or time window, so analysis focuses on the problem area without overwhelming memory. You finish by analyzing timelines and metrics. Look for long kernel durations, low occupancy, or memory-bound patterns and interpret why they occur. Then implement targeted fixes, improve memory coalescing, reduce divergent branches, and tune thread and block sizes, while explaining why each change affects throughput. Once changes are applied, rerun a focused capture and compare metrics side by side. If things go wrong, a key tip: rerun with a fresh debug build and simplified input to isolate whether the issue is build, driver, or code related.
Thanks for watching. Consider subscribing if we helped you today.